Okay, we are live. Live. Because I have to wait a whole day to go live. I didn't know YouTube made you do that. So, basically what we're doing is we are making a video game in Python. If you've ever played Final Fantasy VIII, it's called Triple Triad. This is, I have no intentions of releasing anything that I make today, obviously, because I didn't make it. But I'm, trying to get some practice on Python, specifically, and I love video games. I want to make video games. I want to automate video games as well. I love automation. I love efficiency. And so the idea is I'm going to make botting programs for video games. Doesn't even have to be like an online video game. Like I had an idea of making a game for RuneScape, or making a bot for RuneScape, but I don't know, I feel kind of bad doing that. I feel like there's no point either, because there's just so many bots for that game already. That like, what's another tree chopping bot, you know? Like, I'm gonna learn from it for sure, but I'm also gonna learn from making a bot for like, say, Diablo or something, you know? Or what I'm doing right now, making a bot for Final Fantasy VIII. And so, I am... The reason why I'm making this is, specifically today, is I'm going to be hopefully finishing my Triple Triad remake. And it's just the basic rules of the game. The further you get into the game, the more rule sets there are, but I don't think I have... I don't think I have the desire to add those rule sets, because I'm still very, very early in my programming ability. And I may come back to this later, however, looking at my code, I feel like it's really, really messy. And that as I get better, I'm going to get better at coding and more... I could come back later in the future and then remake this completely differently and more efficiently, way better. And then, if I do, I can add those rule sets in. But the intended purpose of making this bot was that I could, so I could automate the first disc farming of 20 Elnoil cards to get the main weapon of Final Fantasy VIII. Squall's legendary weapon in Final Fantasy VIII. And so this, see the bottom right, I'll go ahead and enlarge it a little bit. This is what I have so far. I have the cards. They randomly generate for each player. It's a coincidence that these two spawned together. And so you can drag a card and you can play it on both sides. I'm not going to be able to show it on here, but the cards are numbered 1 through 9, but they have the potential of having an A, which technically is just considered 10. And so if I was to play an A, it would crash the program, so I just need to figure out how to play that. And so each player can run out of cards, but in the game technically it's not going to happen. But there was a little bug that you saw there. Let me go ahead and replay it. There was a little bug where if one player finishes their hand, then we can't play, or... Oh, there was the A bug. Yeah, so we're gonna play... One player ends up with one card, and they're gonna steal the enemy's card. So that is a bug that could potentially have to be fixed. Potentially, we could also just finish the game, because as far as like how the rules of the game go, we're not going to we're not going to get to that point anyways before we have to start a new game. So I think that's just a bug that we really don't even have to care about. And that can be fixed by just putting a game over or game win over the top and then a reset button. Alright. Oops. So that is our remake of Final Fantasy VIII Triple Triad. I'm gonna go ahead and leave that up. I am doing this on the fly, so I'm going to be a little sloppy today. Alright, so we have our code here. And so the next to do is currently passing a string of numbers instead of integers into the mouse up section. The mouse up section is down here. Mouse button up. There, mouse button up. So the way I'm handling the logic of the game is when you press your mouse button down, there's stuff that will happen. So if, else, etc. And basically, you hold your mouse button down to select a card. Then you have mouse motion down here, which just when you drag a card, it's supposed to drag, but I had to get rid of that for some reason. We'll go ahead and add that later. And then run. So there should be a card dragging mouse motion kind of a thing, but there isn't. Oh, there's another bug too. If you happen to miss the grid, if you happen to miss, like you're playing a card but you miss the grid, then it doesn't play the card, and the card still disappears. It's another bug we have to fix. And so finally, there's a mouse up, which handles the logic of placing the card. It handles which side you're placing from as well. And then finally, see at the bottom in the console, we are printing out for a little debug the card numbers. And so, if you see this here, I built a card class for all the cards. I had a choice of either creating all 110 cards individually, making them basically their own function, or making a card class and then creating the values for each of these cards right here. So this is all list of all 110. And actually, funny story on that. When I first created this program, I built a card scraper. That's something I learned in my Python classes, how to scrape information from a website. And so our card scraper here. And so I've got 4 links to different websites. And so it downloads the image. It has a function that downloads images from the website, and then just made a little for loop for URL and URLs, and then grabs the URL and then soup, beautiful soup. This is my first time working with beautiful soup. I don't fully understand that that module for Python, but that's, from what I understand, that's how I was able to download all the images, I think. I made this a week ago. So function to download. Yeah, find all image tags in the HTML. I think the beautiful soup just parses. I mean, that's what it says here. But it finds all image tags in the HTML code off of the website. And then it's going to, yeah, find all. That's what it is. Soup finds all the images on final image tags. Oh, where do I input the website? Here we're extracting. So we're finding all the image tags, we're extracting all the image tags, we're creating a directory in our main files here, which is basically downloaded images right here, which these are all the cards, and then we're downloading the images. It's just a basic for loop to go through every single image tag. There was 4 total URLs, so we just had 4 URL in the URLs, and then there's another for loop to extract all of the PNG images. And we're downloading them, and then we're placing them into the directory here. And then just in case we were to fail any of the images for the all 110, here it is. If name equals main, cards have been scraped. And so that is our card scraper. And then we used Tesseract. You know what Tesseract is? It reads images for letters and numbers, and it does its best that it possibly can to give you an accurate reading of the numbers on that. And so non-image detection. Which one is it? Extract numbers. So I wrote a program first that didn't work. So this is extract numbers 2, and this one did work. So we're using PyTesseract, right? And then this basically just shows where PyTesseract is on my computer, because sometimes it has trouble reading it. So sometimes you have to put this line of code in so that it can find Tesseract. Then we need a function split image. We'll get into that here in a second. So we're getting the image from downloaded images. Folder path, downloaded images. That's where that previous program downloaded all those images to. One sec. Music just stopped playing there for a second. I just did a hop accounts. Okay, so for image in image folder path, that is our downloaded images folder. We're going to convert the image. And so what Tesseract requires you to do before converting as accurately as it possibly can. Let's sneeze. Whew, okay. What the hell did I just do? Okay. So we need to convert the image, right? First, we're going to take the image. We're going to convert it to grayscale. Oh, sorry, we cropped it first, right? So if you look at these cards, we don't need to read the whole entire card. We just need to read the numbers in the top left and the letters. So we cropped the card. I'm going to need that. List. So we crop the card, and we convert it to grayscale. And then we convert it to black and white. And the threshold variable here is just how here it is. How strong do we want to get rid of background noise? If you look here, there's tons of background noise behind that. And so I don't have the full anymore, the full cropped square, because I had to split them. But by getting rid of the background noise, converting it to black and white, and then inverting it, because the letters are white, and Tesseract does well if the letters are black compared to white. So we had to just invert the image, and then we ran that for I section, enumerate sections. Where's our... Okay, so this line of code here we didn't have originally. because we didn't split them into sections, because we didn't have to begin with. But by not splitting them into sections, we only had about 25% accuracy of the lines we were reading. And so running the program originally, we figured out that the program would only want to read the numbers on the left and the right, but not the top and the bottom. So then we had to go in thinking of ways how to fix that. And what we came up with was to split the image into 3. And so what we have here is top image, the left and the right, and the bottom. And so by doing this and reading all of these numbers for all 110 cards, that's 330 different images Tesseract had to read, we still only got about 54% accuracy. But 54% to me for only 110 images is completely fine. I just went in, I printed them out into a notepad, I went in myself, and then I changed the numbers for each. I corrected the numbers and I filled in what was missing for each card of the 110. Took like 30 minutes. It was really not that bad, and it honestly would have been way quicker if I didn't use Tesseract and I just assigned the values myself. But where's the fun in learning if you do that? There is none. So back to this, after splitting the images, this is for I section, that's the sections of the black and white images. We went through, we used our Tesseract here, image to string, converted the image, detected the letters and numbers on the image, and made them into strings. Which, thinking back now, I wonder if I could string to integer. No. That would have saved a lot of time. And confusion later on of the part I'm at right now. But, convert them all to strings, and then what we output was the numbers was the output. Accuracy, this is just my formula to detect the accuracy. We have the counter here, and then calculated the accuracy through each iteration in the for loop. We added to the counter as well as counted the length of the extracted numbers. So 440 total numbers for 110 cards, 4 number values for each card, 440. And then we have a total accuracy, which is accuracy, length. So say they printed out 3 numbers, then there would be 3, and then the next one printed 3, and the next one printed 4, that'll be 10 throughout the entire thing, which ended up to be about 54 times 4. 216 numbers total were printed. And then through each for loop iteration, we added the 3, the 4, the 4 to get to that number of total. Divided by 440. And we just rounded it up so we don't have a nice, even, nice, good round number. And then F string printed, average accuracy times 100 to get 54%. And then this was just showing the image while I was converting, so I can make sure that I was getting the good threshold, getting rid of a lot of the background noise, etc. Alright, next step was, I believe next step was starting on the game board. And so I have a whole bunch of pictures. I didn't save them individually of like the work in progress of the game board, but I'll just explain it out and look at those. Look at those pictures. So first up, we had the grid and we had the cards. On the left and the right side, we had the grid, the cards, etc. The cards were unplayable, and the cards that were generated between the left and the right were the same. So then we had to go in and, where's it at? Maybe down. Not there. The reason why a lot of this is not commented out is going to be really tough because, again, like I said, I'm learning. A lot of this code was taught to me by ChatGPT and was generated by ChatGPT. So a lot of this I did not write myself. I had help. But if I was to write this myself, I don't think I would even be at step 1 yet. But I'm using ChatGPT as a way to learn on my own, away from classes, and to create things on my own. And as I have questions, I'm asking ChatGPT. So, yeah, functions list. So we have, I guess I can come here, the functions list, player's hand. This is where we draw the player's hand. And so we have the position on the screen. Sorry. Remove that. So we have the position, this function right here. We have the position on the player's screen. I just realized I went through all that code, like showing you guys, but never actually like was actually showing it on the screen. We're just gonna roll with it. This is our first video, anyways. It doesn't really matter. We have our X position, and that's basically on the left or the right side of the screen where the cards are gonna spawn. We have the images, which is just iterating through the images. Then we have max items, which is a variable up here. 5. Where's it at? Not there. I know it's up here. Might have changed it. Yeah, because I think we reassigned it to these here. Interesting. Wonder if we have the max items on here. Okay, so we should have a variable called max items, which should just be assigned to 5. I don't know what happened to it. The code isn't broken. I'm not gonna question. It's working as intended. Classic Blizzard. And then just the side, left or right side. Okay. This is where we spawn cards. Yeah, player's hand. And so we had to split left and right side in our event. And then we add dragging image here. This is where we're able to drag the image onto the grid. Drag offset. I don't remember why I did this. I wonder if we comment this out, if it'll still work. Oh no, that breaks everything. Does not break everything. Okay. Yeah, it's not, doesn't do anything right now. I think that line of code was for dragging the dragging animation of the card, which was handled down here somewhere, is no longer handled down there because it was breaking the game at one point. So I commented it out, and then I guess I deleted it somewhere down the road and just never like bothered to fix it. So we don't need that for now. Let's start commenting. This code. My card. Good. Okay. So we just our original version. The left and the right side were the same cards. The grid was drawn. Could not play anything but we had our framework of doing everything. And so the next one we separated the player's hand. Like I said, this handles the separate logic of the left hand and the right hand. And then we added the ability to drag the cards onto the grid. However, we had a big issue, which took me so long to figure out. But we figured it out. Eventually, we figured it out. When we would drag an image onto the grid, it would be covered by the background. And so we had to figure out a way to not draw the background over the cards. And instead of figuring that out early, I just stopped drawing the background. And it worked. And then we figured it out later. And so we could play the cards, and then each player's hand was separate from each other, separately generated. And the cards were squished a little bit more together, which made it kind of hard to select the card that you wanted, right? Let's restart. I'll show you. So you see when if I mouse here and I click, it's gonna click the ward card, right? This card, right? Oh, can't play it. I need to fix that bug. Bad. Okay, so if I click here and play the card, it plays the card above. It doesn't play the card that I was intending to select. It's another bug we gotta fix, but by spreading the cards out more, it fixed it on its own, which I could just spread the cards out even more, and it'll fix itself again. Or I could somehow figure out the logic of not being able to select the card in that field. But that's a problem for later. What's more important now is adding the logic of taking a card, which we're going to begin here in a moment. And so yeah, so that's where we were. We would play a card and it would not disappear, and the card would appear on the grid, hidden behind the background, so we just stopped drawing the background. We were good. But there actually was an issue that came up after that, which was we started wanting to add the ability to, after playing a card, it disappears. Right? So I just played that card and it disappeared. I'll play this card, it disappears. Play this one, disappears. It had an A on there, so it broke the game. Alright, play this card, disappear. Play this card, disappear. Now, those cards, I wanted to create the ability for the cards to vanish, disappear after being played, and I was having a lot of trouble doing that until I figured out that my code was working. However, by not drawing the background, it was not disappearing. So let's see if I could do it now and show you. I don't think I fixed that. I think it's still... Yeah, so okay, this is actually good. This shows you what my fix was. And so when we initially start the game, I just disabled drawing the background. So playing the game, it's just it's a black screen. There is no screen fill at all. And we're gonna play a card, and it's gonna disappear because we updated the background behind the card. That card is still there, and if I comment this out, I believe it is. Yeah, draw background. If I comment that out, okay, so yeah, you see the card is still there. The card is still there. And so, basically what it's doing is it's playing the card. The image still stays there. However, when we uncomment this out, I'm gonna break it. We're gonna fix that bug first. Now, it updates the background and hides the old card. And it's not that the image is actually staying there, it's that because you don't draw a background, images stay up. That's how Pygame is. You have to update the background for it to disappear. That's not the best way I could describe it. Okay, so if there is no background, anything you draw on that background stays on that background. Because you're not drawing a background at all, at no point during the main loop, which is right here, while running, during this main loop, nothing refreshes. So it stays in the background because nothing refreshes. I hope that makes sense. Like the background is just one image that does not get refreshed. But the way video games work, it's multiple images being refreshed anywhere from 30 frames to 144 frames or 240, whatever it is, whatever your computer can play of the game and whatever the game supports. And so because it never gets refreshed, it never goes away. However, after playing a card, we do refresh the background now, and the card does disappear. Alright, let's run it again. Alright, so our next iteration, we drew the background. Took 2 hours to figure out the logic, and it took 2 hours to figure out to draw the background outside of the loop and to do those 2 bars on the side, refresh those 2 bars on the side anytime a new card is played. Because at anywhere during the loop, if I am to refresh, it's going to cover that grid in the middle, and you can no longer see the cards that have been played. Whew. Alright, and then now we're back to where we are now. We're gonna figure out two things we want to figure out today. Again, I'll show you in here. We are printing off card with the number values. We need to get rid of all the information in there, minus the number values. We need to convert them to integers, and then we need to apply them to the card variable. And so that's problem number 1. Problem number 2 is going to be yeah, we'll do that. Problem number 2 is going to be that we need to figure out why anytime you play an A, it breaks. And so we're gonna do that. We're going to play an A card and figure it out. And so it's telling us line 110 and line 123. Read card data from text. That's a function that we made right here. And so I think what the issue is that it's expecting an integer, but it's getting a letter. File name text file. This line right here. The source may be a string representing a Python expression or a code object. Code object as returned by compile. This must be mapping. I have no clue what I read. we're gonna do what I've been doing the whole time. We're gonna get in the chat GPT and see what the issue is. And we're gonna learn. Evaluation of the card data. Specifically, it seems that eval is trying to interpret a variable named A which is not defined. Text files properly interpret. Code assumes you're trying to evaluate card data, then look something like card or card B. That's incorrect. So this problem arose because of the most recent thing that I've added to the code, which was this right here. I think. Not defined. Yeah, read card data from text. So basically what we're doing with this is that we are, so say we have a card that's placed. We're taking a snapshot of that card and then applying it to another program that I made. That image detection 2, yeah. That will take an image and compare it to another image. And so it takes a snapshot of that image, then it goes through the downloaded, goes through every single one of these cards and detects which card is which. And somewhere in here it's broken. Mine starts with file name. So yeah, so it matches those cards and then it runs this function. Data is not non-card numbers equals card data, print card numbers. Else print. Okay. Let's see how that goes. Same thing. Tuple object has no tribute replace. Different. Wait. We don't want that. Oh, 5983. Okay. Ooh. Yes, it placed it. Okay, we fixed it. Okay, so basically what we did is we I have no clue what the variable name. I'm gonna having ChatGPT explain it. But basically, from what I understand, is what's important was that if car number equals A, then we just apply 10 to it. But when we get the output, we're still going to get A. And I believe later in our code, we're going to have to, if car number equals A, car number equals 10. All right, so we're opening text file path, which when we call the function is right here. Text file path is the car list value.txt. That is our list. And then file name itself is that yeah, so earlier we matched the card, and then we're taking that matched card, which is selected card path, find matching image. And so we matched the card. So we matched the image in this downloaded images folder. So say Chubby Chocobo gets placed, takes a snapshot of that, applies that snapshot to the downloaded images, iterates through every single one, and then finds, oh, it's Chubby Chocobo GF card. .png. Then we're going into our card list value, Chubby Chocobo GF card. We strip a little bit so that it matches the name, the file name with here, and then it gives us these values. I have to show you down here. It says Chubby Chocobo GF card is card. Hold on. Is card 4948, and then it extracts everything to the right of this number and prints it. Sorry, right of there, which you can't see. Go up. Okay, it extracts this information here, and then it takes that, applies a card number, applies it to a different variable, and then it outputs this. So we have, hopefully those are integers. So we have 3. We have A, which converts if card number equals A, it's technically a 10. Then 1A, and we're not technically doing Chubby Chocobo GF card down here. It's that the card that we just placed on the left is the card that is being read here. So 3A, 1A, and then it gives us these, which are hopefully integers, which we can then apply to our card class, which would be our next step. So if line starts with here, here, if it starts with file name, if it starts with Chubby Chocobo GF card, we apply variable name to it. Oh, sorry, if line starts with file name, yeah, variable name equals card data. Line.split. Hold on. Yes, so it splits this using the equal sign as a split point, and so it applies 2 variables to it, or 2, I guess, variables. This is the first variable, this is the second. That's when we've got, sorry, split, and then we're gonna strip line.split. Yeah, splitting at the equal variable name because we're strip. I think here is where we strip out a lot of what's not necessary here to give us this, maybe. Stripping the white space. So we're just stripping the space. We're stripping this from it, the space, to the left of the card. Data.replace. It removes the parentheses right here. Let me split this real quick. Split right. Okay, so we're stripping the parentheses. Into a list of strings based on the commas. Yeah, so we're taking the parentheses off. That's here. I'm not sure why these are here. And then with the split right here, we're splitting each string. They're currently strings, so they're not technically numbers to the computer. And then splitting them out by the comma. Okay. And then extracts the card number from the first element of card data. item.strip for item. Card number equals card data dot replace. Yeah, so we're getting rid of card here. And so what we're left is just these numbers. And if it happens to be an A, like right here, it assigns 10 to it. Otherwise, if it's an integer, it just leaves it as an integer. And then we're building the final card data here. And returning the card data. So what we're returning is these numbers, which we then need to apply to our card class. Which, starting this project, I have 0 experience on classes. So this is a learning experience for me trying to figure out how classes work. So bear with me there. Okay. Now back into the project. I believe our next step is to then go into game board. Don't need that anymore. We need functions. We need class list. Here, we need to apply it to. So card data is what we're returning from this. Card numbers equals card data. Card data is not none. Okay. So this is our debug here, our line of code for debug, just to make sure we're getting the numbers from it. And then from here, I'm assuming we either get rid of this or we write it under the if else, which I think will be smarter because later on, if there is a bug, then we need to print error card data not found, just in case. Probably not going to happen. In my mind, it's not going to happen, but you never know. Okay, I need the card class now. So this is self.top, self.bottom. So we need to apply. We need to apply those integers to the class, the card class next. And if we get that, then we've done what we want to get done for the day, and we could just move on to whatever we want, which may be like maybe adding a score system, maybe starting to add the logic of taking the enemy's card, which I think the score system would be the best. If you look at on the bottom left, if you look at the if you look down here at the cards, one issue that I'm facing is that in the game, the cards turn red when you take a card. And I can't find a website where I can scrape all of the red cards off. So what I think I'm going to do maybe is to, I would have to change the logic of the grid drawing system to be able to be red or blue depending on who owns the card. Instead of just turning the cards red. And then also I want to add a score system above the grid up here. So this would be left side, this would be right side. Adding a score system to that. And then after I add that score system and I add the logic of taking a card, technically the game is done. There's just bug fixing at that point. So I'm very close to finishing this. Very, very close to a finished working, not finished, a working product. After I finish the bugs and fixing those, I should have a working product. However, I don't think I will, because the intended goal of this program was to just make a bot for a video game. And what I'm doing right now is not even necessary. I'm just using it to learn. But it's been fun. I've enjoyed making a game. And what I'm thinking of doing next actually is making like kind of an Adventure Quest ripoff using Pygame, which Pygame is not the it is not a good video game making program. However, Adventure Quest was made in Flash back in the day. 22 years ago. It was made in Flash 22 years ago. It's crazy. 22 freaking years ago. If Python can't remake it, then Flash is better than Python. Is that the logic, you know? So Python can definitely remake Adventure Quest. No doubt about it. Or, you know, I could do it in Godot, which I was learning a little bit of a Godot in the beginning, but that kind of like sprung me into learning how to code, is messing around in Godot. But, however, I don't see a point to swapping into Godot right now while I'm still learning Python. I feel like it would just take away from the time that I'm spending to learn to code through Python, and I don't want to do that right now. I want to go all in on Python. That's the main reason why I'm building this in Pygame right now. Okay, next up, we're going to apply the numbers that we just gained to the card class. I don't know if you guys watch Pirate Software. Yeah, the creator of Heartbound. Haven't played Heartbound. I need to get it. I really like this guy. I don't buy games right now. I try to save up as much money as I possibly can. But what's amazing is that he offered all of his soundtrack in his Heartbound game for free. Unless you're re-uploading with no context at all, like nothing adding on to it, he's not going to copyright strike you, which I think is amazing. I think that's the OST that we're listening to while I'm coding right now today, which we're going to be listening to for a while until I can find other music to play. But I think it's just such a smart idea that he did that, because now I immediately want to support him, and he's offering me free, without having to pay him a single dollar, free music. Just gives me more incentive to want to support the guy. Like, just such a smart idea. If I ever get to the point where I'm, which I hope I do, you know, I don't hope I do, I know I will. If I'm developing video games like that, I'm going to do the same thing as he's doing, and offer my music up for free so that anybody could use it as background music and they don't have to worry about copyright. I think that's just awesome. Okay, back to the code. To apply card numbers to the card class, you can instantiate a card object using the extracted numbers. You need to ensure that the card numbers are integers before passing them the card constructor. I believe they're integers. Let's just go ahead and print type. Just to make sure that they are integers before we go in and completely... Oh, it's a tuple. I don't know much about tuples. So yeah, this should be integers, but I'm not sure how to print whether they are integers or not based off the tuple. Maybe do card data. Print card data. It'll tell if it's integers or not. That's probably, no, it's return tuple as well. Here's how you can use a card numbers tuple and instantiate a card object. If, yeah, so we're gonna keep this if card data, this if else statement here up. I just think it's gonna be smart for later. So event type, mouse button up, that's all the same. Yeah, so ChatGPT is telling us card numbers equals card data. Card object equals card. I don't know why it throws. Why does it throw this, the star in there? It's my question, like. We're gonna ask it. We're gonna learn. The asterisk operator in Python is used for unpacking iterables like lists, tuples, etc. When you use the star before an iterable in a function call, it unpacks the elements of that iterable and passes them as individual arguments of the function. That's why. But basically, it's taking the 4 numbers of the tuple that we have, separating them and applying them separately to the card. Containing the values. For initializing a card object by adding the asterisk before card numbers, you're essentially unpacking the tuple into its individual elements and passing them as separate arguments of the card class constructor. Okay, so I do think it's kind of cheap to be using ChatGPT to be building this, but at the same time, like, being a beginner at Python, like for this instance here, like I just taught myself something new that I'm going to remember in the future and I'm going to apply in the future. It just, yeah, I'm being cheap and I'm using ChatGPT, but like the alternative is using Google and just wasting time. And I'm still learning. I may not be learning as much as if I was to Google, read an entire article about something, and then maybe applying it into a different script or into the console to figure out if I figure out a way to implement it. But I'm still learning, but I'm still getting better, and I love that. I love that ChatGPT is a thing now that I could use to learn, and I've been doing that lately on my phone as well. Like I work as a chef. I'm asking ChatGPT different questions about why, for example, this chicken that I had really weird strings on it, and I googled why, or I didn't Google, I ChatGPT'd what are these strings on the chicken breast. Turns out it's caused by steroids that we give the chicken, and if it has terrible living conditions with steroids, it has more of an option, and it's something that's showing up more and more today, which, like, before I would have just thrown that piece of chicken away and not used it, but now learning that that chicken is perfectly fine to eat, there's actually absolutely nothing wrong with the quality of the chicken, it's just a matter of how the chicken breast was formed. I saved a piece of chicken. Saved money for the company. Like, ChatGPT is amazing. Alright, back to... Keep getting sidetracked here. Okay. So we're extracting the card numbers here. Extracting the card numbers equals card data, print. And here I need to start commenting on this so that I don't wonder what is happening. Card numbers to card class. And so we're going to come in and we're going to print to make sure that we're getting this correct. Card object. Else print, return. All right, we're gonna give it a go. We're gonna see. Card object is card. We did not need to put that space in there. Card 3453. We should also print type. Just to make sure it is a card class. Yes, it is. You can't see on here, I believe, but I'm going to show you. Card class. Dot card. All right, we did it. We got what we wanted to get done today, done. And from here on out, it's all fun. It's all fun and games. I try to spend at least an hour minimum a day learning. A lot of the time, I'll go way above that hour. Some days I don't want to go above that hour. So I'll throw on a video. I'll throw on like, most recent one I was watching was how to use PyAutoGUI, and something else to detect objects in Diablo 2. But we're not going to do that right now. We're going to continue developing our video game. So the next step, I think we're gonna ask ChatGPT to comment out we're asking ChatGPT to comment out all of our code so we understand better. Something that I should have done sooner. Actually, I should commit here. So what we did today was fix the number detection, fix the card number detection, cards, card number detection system, and applied the numbers to a card class. To the card class, not a card class. Commit. Currently passing string numbers to integers, change to integers. Done. Apply to the card class, then save the card class on the grid for later information. Save the card class on the grid. Okay. Save the card class on the grid for later information. So store the card class on the grid for later information. So that's, I guess we're not done with what we wanted to get done today. I'm not sure how we're gonna do that. One step at a time though. Plugin.initialize. Where did I put that? All of this. Standardizing the Pygame window as well as Pygame window sizes as well as colors. This is what these lines of code do. All file paths are here. Image paths, list of paths to all PNG files in the image folder. Okay, so the image folder is just a downloaded images folder itself, but the image paths is a for loop for all the images in there, and then the images themselves are here. Yeah, this is contains all of the loaded images. Wouldn't these two technically be the same? No, because one is OS and one is Pygame. So it's loading the images themselves, but the image paths are just the paths to the image. Okay. So images. Number of images loaded. Number of images that are loaded. Variable. And this is basically just the whole player's hand. Yeah, this just handles the logic of the player's hand, scroll POS, scroll position. Not sure what that does specifically, but I'm sure it does something important. And card app position, just for loops, finding where the card is. I gotta sneeze. Yeah, I've been talking, but I didn't unmute my mic since I last sneezed. Nothing important. So that previous code, when it's down, it handles the dragging card logic. When it's released, it handles placement on the grid. It handles detecting the card and creates the card class. And then somewhere here we should be able to assign some type of variable so that we could store that information on the grid itself. So here, okay, so this logic handles when we release the mouse, it picks the side that we already assigned earlier through here, this line of code. It figures out which side it was placed from, and then from the left player's drop-down images, it subtracts 1 to the max drop-down items left. It removes the card. And the reason why, I believe the reason why we separated left from right is that if we were to place a card on the left, from the left into the grid, it would also apply that same logic to the right side. So when you play a left card, right side's going to play a card at the same game tick, and it's also going to disappear a card same game tick. And obviously it's a 2-player game, so we need to separate the logic. Grid start X, I think. Position of the grid on the screen. I think this just helps determine if we played something from the left or played from the right. No. No. Yeah, I'm not sure here. It iterates over each cell in the grid. Okay, this is cell logic here. So this is where we're going to apply the card logic. It checks if the mouse position is within the current cell and that the cell is empty. And I believe we should be able to... No, we can't. I didn't know I added that. Well, technically I didn't know ChatGPT added that, but we can't place a card on top of an already placed card. That's good to know. I hope... Oh, shit. So, I hope somewhere in what I just made... Yeah, that's a bug we're gonna have to fix later. How it gives the player one of the enemy's cards. No? Why didn't it do it that time? Maybe... So we're gonna start with right player first and see. Yeah, so if right player goes first, it takes a card from the enemy. But if left player goes first, does it still take a card from the enemy? It does. Oh. I don't even know where to start on that, but we're not going to do it right now. Checks if the mouse position. If so, it centers the dragging image within the cell and blits it to the screen. Blit just means it appears on the screen. It updates the card position. It's going to be somewhere in here. that it takes the card, I believe, maybe. Maybe with this line of logic here. And I think all we have to do is maybe like, that or it could be this logic here. Or just make like an if player has 2 cards left, or if player has 1 card left, then some type of logic. Let's drag image to none, and indicates the card has been played. The loop breaks after a card has been played to prevent multiple cards from being placed in the same cell. Game.mouse motion right here updates the screen. No. These parts are responsible for handling mouse movement, drawing the camera effects, and updating the display. Technically, I should be able to delete version of the... Yeah, that code is repetitive, and it doesn't need to be there. We just need to... We're going to save that code elsewhere, in case we actually do need it. So this just needs to move somewhere else in the logic. All right. For some reason, without that code, we're not updating the loop. And I think we can do like this. Yeah. Of cards not being played. Yeah. So, as it was, it would initialize the running of the screen and then make a condition for if the screen gets closed, and then it would wait for mouse button down to happen. But what we've added is if there's no card being played, we're initializing player's hand, which we probably don't even need to do. We just add if card isn't being played. No, split out flip. Grid. We need to redraw the grid again. Where did I put that? Not where I put that. I deleted it, didn't I? In here. Oh no. I think it was here. Draw grid. I think it was right there. Yes, it was right there. So we are now drawing the grid. We're now running the player's hands. I wonder if we're going through 2 iterations of drawing the player's hand before the game initializes, which is not a big deal because it's only 2 and it's not like thousands. Now this is an issue because I have no idea what this does, but it's already being handled anyways, I believe. Maybe that could be the... Ooh. No. So maybe in here, under mouse button up, something here could be causing the issue of trading the cards, maybe. Because to me, it looks like this is playing the card. That's the code of that, literally. It's just not necessary at all. It's enumerating through the cards. This assigns a variable when you drag an image. When you like click an image and hold it down, then converts it to a dragging image, which then can be dragged around, which is currently broken. We can comment this out as well, I believe, because yeah, because along with why does it trade images though? Has to do with somewhere here, I think. Because side left, player's hand equals left drop down images, which is a function that we created. No, it's not a function we created. It's a variable we created using a function. We subtract the card. When we play it, mouse button up, this is where we subtract the card from. I wonder why screen width divided by 2 hat. I'll try separating these out. 0. Actually, change that. To trade cards. Check L. Okay. Right. Completely broke the code. Okay. Cancel. I might have just found it. I feel like I just did. No, we just traded cards. Now we're trading even more. God damn it. Okay, so that helps. It happens when a player has one card left. It just happens randomly. Maybe it only happens when the right player. Happens when a player reaches 0. Yeah, if length drop down images is greater than 0, if not card what? Inside the game loop, if not card played, down here. If length left drop down images greater than 0. That's it. Technically, we already have that up here though. Length left drop down image is 0. And if dragging the image left is not none. But if not card played, we'll try it. Length drop down images is greater than 0. Right card image equals player hand. Okay, stays at 0. Did we just fix it? I hope we did. Not debug. We did fix it. It did still take the card, and that could be handled up here. If we just comment these out completely, I wonder if go ahead and comment that out completely. What happens? They're not played. Okay. We do need this. Maybe we can comment out a section of code at a time, and I know exactly what to start with. What we're going to start with, line of code right here. Comment that out and just pass. Comment that out, pass that. Comment that out and pass. We broke something here, especially if I'm like. We're not playing cards. Okay. So that is important. That we can now comment displays the card to the grid. But it helps. Helps play the card on the grid because mouse button down does not actually play the card at all. This is being applied under the mouse button up somewhere. Okay, we fixed a bug. I'm happy. We just missed the grid. That's why that last card didn't play. Did we fix the bug though? Okay, we're gonna hope that that bug doesn't come back. And then we're going to store the card class on the grid for later information now. Okay, we need to commit before we do anything else. I did not mean to run card. Did not mean to debug, I meant to run. Okay, to store the card class information on the grid so that the program can recognize adjacent cards and determine whether one card can take another, you need to modify your code to associate each card on the grid with its corresponding card object. Just want to make sure I am printing taking card, cannot take card. Okay. When a player places a card on a grid, associate the card object with a corresponding cell in the grid. Card object with the corresponding. When determining whether a card can be taken by an adjacent card, retrieve the card object associated with the adjacent cell in the grid and perform the comparison. I understood about half of that. So it looks like we need to assign your grid cards. Grid cards. Good logic. None for blank in range grid. Size 1. For blank in range grid size 0. Grid size 0. Okay. Inside the mouse button up, event handling block. Cell rectangle collide points. Inside the mouse up, event handling block is the card in the grid. A function called check card take. Card I, card J, underscore J, card I, card J, other card. If card I 1 is greater than or equal to 0, what? Grid cards. Card I minus 1. Card J. I don't think what I'm making is correct. True. I think what we need to do is assign each grid a number, right? And if card can take... So if card in grid number 4 can take card in grid number 1, so visually this would be card grid 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I place a card in 4, that can take grid number 1, so it would be this. Well, this card can take grid number 1, so it would take it. So it would assign grid number 1 to player 1. That's how I see this in my mind. Assign a number for each grid and check from there. Check, for example, grid 4 can take grid 1, it will, and then assign it to the grid. Because that just makes more sense to me than what ChatGPT's having me doing. So just a number of coordinates to each grid cell, and then check if one grid cell can take another based on the identifiers. This approach simplifies the logic and allows you to directly compare the identifiers to determine. And later on, it does make sense because if I'm to continue to update this program, I can then go into grid number 1, for example, and randomly assign an element to that grid. So if the card has that same element, it boosts that the numbers, every single number of that card. So we're not going to do what it initially said. To index. We don't need that either. No times grid size 1 plus COL. I wonder what COL here stands for. Define function to convert grid coordinates to unique identifier. No times grid size 1 plus all. Grid to index. Or index to grid. We're gonna stop soon. I'm starting to get a headache. But I would really like to get this done. Each grid is assigned a unique identifier using grid index function. Function can take which is under card class, can take checks whether a card at a given grid index can take the card at another grid index. Okay. You iterate over adjacent grids, check if they're within the grid boundaries, and then check if the card at the current grid can take the card at the adjacent grid. If a card can be taken, you update the game's state accordingly. Okay. EOL column. It's a row column. So now inside a mouse up, mouse button down, mouse button up. Okay, I saw right. Grid interaction is best play here. Back one. for adjacent index and adjacent indices. Zero is less than or equal to adjacent index, which is less than grid size. 0, grid size 1. If can take current index to adjacent index and taking card. Update game state. Current index, adjacent index. Break. Else. And cannot. So can take. Import card, import can take. Can take. No, that's not how it works. Okay. So big game state. Can take. If in can take. Drew top. Jason, Jason column, not in. Jason column in adjacent. If 0 center equal to adjacent, which is less than grid size 0 and 0. And 0 is less than or equal to adjacent column less than grid size. Adjacent card equals card at position row. Position column. Position row. Column. Okay, so adjacent card equals card at position, adjacent row, adjacent column. If adjacent column. If adjacent card is none, okay. Card is not none, and if card if adjacent card is not none, and if card object can take adjacent card, print taken card, and then update game state. current index, current and update game state, current index, grid. Index, adjacent row, adjacent column. Just put it there. And break. Why is update game state underlined? My question. Cannot. Print taking card. Oh. Cannot unpack non-interval event. Treat it as an interval, not going to be unpacked in adjacent. Affecting adjacent is to be an interval tuples, but instead it's an integer. Adjacent is properly constructed as a list of tuples containing correctly. Make sure that adjacent indices defined properly before the loop. And it should contain tuples representing row column. And the loop should iterate over these tuples correctly and packing them into adjacent row. Right? For adjacent row, wait. Here's the corrected loop. Getting better. Okay. So it's just when we go to take a card, but when we place it, we're fine. There's nothing next to it. When we go to place the card, when there's something next to it, and it's under the class, yeah. Surface.surface object has no attribute bottom, and then 160 for the object. Let's we need to print the card somehow. Make sure that we actually have a card class, because this is scaring me. No card object found. But earlier we're creating the card object when we button up. Maybe it's just that we need to we just need to tell the computer that it's gonna be something later on, maybe. And that here we can We don't get... I'm not gonna do that yet. Access each with bottom on a package. Yeah, we're not returning a card class object. Let's just... No. Yeah, let's, Third, 1. Let's just do that. And let's just see. Bottom. The card at position grid contains instances of the card class, not image surfaces. When placing cards onto the grid, make sure to assign card objects. Fresh boy. Okay. So I know what our issue is. The issue is we're not receiving card objects. It's not working. Did that seriously just fix it? I just had to delete break. Bruh. You're kidding me. You're fucking kidding. Alright, just gotta double check that it's actually working and that we cannot take. Yeah, cannot take. Why can I take 3? Why can this not take 2? But it can take and then crash. That didn't fix. But that works. Taking card, cannot take card. So we got 3, which would make sense because there's nothing below. This can take. Taking, cannot take because there's nothing. Cannot take, cannot take. We only got 2. Why did we only get 2? Can take. This cannot take, cannot take. Okay. So, it's not working. But we're closer. Can take. So taking card. Cannot take, cannot take. So why is that fucking broken? So that can take. So it's taking. Taking, cannot take. Take. Take, cannot take. So cannot take, take. It says it's taking all of them. Well, somewhere our logic is broken. And take adjacent card. taking card from above, not from above, taking above card. And card above. We're almost 3 hours in. Okay, so somewhere in the logic, taking the left card just doesn't work. Let's see. But taking the left card there works. So it's the grid. Somewhere is messed up in the grid. Taking left card. The bottom left grid. Taking card above, but not taking the left card. Okay. I'm gonna run to the restroom. I'll be back. Okay, I'm back. Somewhere in my grid logic, it is not correct. I just want to run a couple more tests just to make sure. So, cannot take card, cannot take card. Mess up. 3, we got an 8. Yeah, the grid. The grid's what's messed up. Oh, I'm gonna print the grid. I have a hypothesis here. My hypothesis is that... Okay. It's incorrect. Event type mouse button up. Brian range, grid size, for Jane range, grid size, star rectangle. Okay. Star rectangle clap point is not none, or is none. It is 0. So 0, 0, 0, 1. I think it's that 0, 2. So 1, 1, 1, 1, 2, 1, 3. 2, 0, or 2, 1, 2, 2, 2, 3, 3, 0. Yeah, it's working. The grid's correct. 3, 3. Taking card up. So it's the card taking logic, then it has to be, because I just played a card. I should not be able to take the left card. So the grid is correct. I had a feeling when I was writing that out, it wasn't. We just finished the OST, so we're going to not play music while we figure this out. I'm gonna try something. of card object dot get top. The fuck? I never even made a get top. Greater than. Like that just broke the code. Yeah. That ain't right. Position adjacent row, adjacent column. Row adjacent. Index to grid, adjacent index. Index to grid, maybe. Grid size 1. Column. Next. Okay, the numbers are getting swapped around somehow. That's our issue. So the, I mean, it'll work, but so the card values are being switched around somewhere in the code, and what I could do is just reorder the values. Um, Make sure that actually. Yeah, somewhere in the logic when you play a card versus an adjacent card, it's it's switching the numbers around. And what we could do is just make a function to re-switch them around back to where they should be after playing, which to me is it's a pretty bullshit way to fix the issue, but at the same time it works. So so do we do that? Is the question. uh what did we want to get done today? We just wanted to store the card class on the grid. And we're technically not doing that, so I think we do need to fix this before we can call it a day. um, let's see. Adjacent indices above, below. Oh, you know what? Figured it out. I figured it out. We're good. Left, right, below. That was literally it, I think. But that's just a funny way to fix an issue that works. But so let's see. No, it didn't work. Ah, no. Ah. All right. Cannot take card. Taking left card. Ah. So I think I need to draw this out. Use notepad. Let me see if I can show you guys the notepad. Let's see. Window capture, new source, notepad. Okay. All right, we got a notepad going. Let's just up the font. View. I've never had to up the font. Yeah, we'll just zoom in. All right, so this is how we're when we place the card. This is how it shows. We'll use these two cards as an example. So that card on the bottom left, when we place the card, it reads it as 7365, and then card on the bottom middle is read 2A69. And so that's how every card is read in my card list value text file. Um, but so after we place a card, it changes. It goes from 7365, 7653, and it goes to 269A. And so it goes from being, let's see, it was top, left, no, left, right, bottom. Top, left, right, bottom, and it is now changed to top, to top right, top right, bottom left, bottom left. And so what we could do is just make a function that just reorganizes it. I would like to not do that. I would like to figure out somewhere in this code where we went wrong. So we're gonna figure it out. I'll throw the music back on while we look. Oh. We're just gonna rearrange. That is not heartbound. don't want to rotate clockwise though. Do I? Oh, because hop. Okay. That does not make sense at all. What the fuck? Oh. Hold on. An object left, bottom, right, top equals top, left, bottom, right. So right equals bottom. Hold on. Yeah. So left equal. We're gonna hit the console on this one. Okay, it's defined. Yeah, that doesn't make sense. This is a rough one to figure out. I can't wrap my mind around it. I really think I need a break. I think this is a good point to stop. I'm just, yeah, I'm gonna stop here. I'm gonna give it another go either later today or tomorrow. So thank you all for watching. Really appreciate you. Y'all have a good night. Take care. Bye.